This last video is one where I have to be a little hard because we graphed this one in class. F of x is equal to 2 to the x. This is an exponential function, and this is where we're going, meaning that these kind of functions are what the chapter is all about. If we graph it with a t-chart of values, we can say, well, a good way to start would be -2, -1, 0, 1, and 2. Always good values to use. It's centered around 0. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. Fix that a little bit. Graph these values. You have this one, there, here, and there. Now, we don't need to graph too many more of these to see what's happening. Suppose I could put one more, 3, 8. And we have a function that looks like this. Never crosses the 0 or the x-axis. That is the function f of x is equal to 2 to the x. Then it says draw the inverse one on the same coordinate system by reflecting around across y is equal to x. This is what you were doing in previous parts of the problem. So there's our y is equal to x line. And now we're going to draw kind of the opposite shape. Coming up here, crossing, and going up. And we can say that is f inverse of x. Finally, it says find f inverse of 2. Well, we can do that from the original one. F inverse of 2 means plug in 2 back here. This would tell us what f inverse of 2 is. Because in an inverse function you switch the x and the y, f inverse of 2 would be equal to 1. The original ordered pair was 1, 2, and the new ordered pair would be this one, 2, 1. So when you plug 2 into the inverse function, you get 1. We can do f inverse of 4, and now we can start getting an idea of what this is really saying. F inverse of 4 would be this one, 2. F inverse of 1/2 would be this one, -1. And then it says give the domain and range of f and f inverse. Please tell me you remember what those words mean. Domain is all the possible x's, range is all the possible y's. So if we're going to say what the domain of f is, if you look here, there's no limitations as to what x values you could plug in. The domain is all real numbers. The range, though, this never goes below the x-axis. How do you know? Well, tell me. Take this function and see, is there any value that you could plug in that would make it equal 0? Is there anything you could raise 2 to in order to get 0? No. You cannot raise 2 to an exponent and come out with 0. Nor are you going to be able to raise 2 to an exponent and get anything negative. The range is all y such that y is greater than 0. All positive numbers. Since in an inverse function, x and y are switched, the domain and range get switched. For the inverse, the domain is all x such that x is greater than 0. And the range would be all real numbers.